Hello, this is Mr. Wilford, and I'd like to go over a little bit Chapter 5, Section 2 with you, bisectors of triangles. This is one of those sections where you might want to just take a few notes. We have a lot of vocab here. There's a lot of things going on as far as the triangles and the way that we're going to bisect them. Um, so first of all, there's just a little construction thing here that you can try, or at least take a look at. Basically what you're going to do here is you're going to draw a nice big triangle on a piece of paper, ABC, and then what you do is you fold the perpendicular bisector of each side. So what you're doing is you're looking for example, AB halfway. Remember, a bisector is cutting that segment in half, and we want to be as perpendicular as we can for that fold. So we would want to fold that paper right about here, which is what it's showing here. And you do that for all three sides. And then where they intersect, so this is the perpendicular line here, here, and right there. And they all intersect in that point P right there. If I go up here, there's some terms that I just want to go through here. First of all, when three or more lines intersect at one point, what we do is we call that concurrent. And what we're looking at here is a point of concurrency, where three lines intersect at a point. What we're looking at in this example here is actually the circumcenter of a triangle. So that's what we're looking at in terms of this triangle. And there's a theorem, of course, that goes along with this. And basically, what we're looking at here, it says the circumcenter of a triangle is equidistant from the vertices of the triangle. So if you remember that point P that I just mentioned above, it actually is the same distance from A to P, B to P, and C to P. So what this theorem is saying is that once you find this circumcenter of a triangle, it is going to have the same distance from that point to each of the vertex points of the triangle. Now the interesting thing, of course, here is with triangles is that you can have that circumcenter of that triangle be inside the triangle, outside the triangle, or sometimes in a right triangle you can even have it sitting right there on the hypotenuse. When we throw a circle around that triangle, like in this picture here, this is called a circumscribed. This circle is circumscribed around that triangle, or around a polygon. In this case, it's a triangle that we're talking about, and this circle is going to hit the vertex points of each of points of that triangle. A few examples here that you want to go through. This is one here, especially deals with a little bit of algebra, and they talk about drawing out a triangle here and talking about the circumcenter there. Then there is a couple more terms here that I want to make sure I get to, and that is another point of concurrency, and that is the incenter of a triangle. And this time, this theorem is an incenter theorem. It's talking about the angle bisector. So if you cut these three angles in half, they're going to meet at what we call an incenter. And the thing about this this sort of theorem is that your incenter will always happen inside each of these triangles. No matter what the triangle looks like, when you cut those angles up, you end up with that point, and that point is always going to be inside the triangle. What the theorem is saying up here, I'm sorry, is that point is an equidistance to a perpendicular distance to each of those sides. So these little blue lines are all the same. And again, we have a circle where this time we're going to go talk about a circle inside. So we say it's inscribed that triangle. And it's touching all of the three sides. Another example there. Again, if you have any questions, please let me know. Thanks.